Hey guys, section 8.4 part 3 video. Hey, if you watched part 2 video, we left off here on number 5, and I wrote some additional information to clean it up a little bit, so I want to go back and point a few things out real quick. Had to kind of squeeze that one in, so I was hurrying. So right here on the bottom, where it says y to the 1/3 power, remember recently we did fraction exponents versus roots, and they mean the same thing. So we learned a long time ago that you're not allowed to have a root on the bottom, so therefore you can't have a fraction exponent either. So you could change it to a root, and you could get rid of it that way, and we did learn that. I know this is going to sound odd, but actually using the fractions is a little bit easier. So right here, this spot. So here's kind of the concept, and we're going to look at this in number 6 anyway. If you have a fraction exponent, 1/3, it's just a matter of how can you make it into a whole number. So if I had 1/3, I use 2/3, and that gives me a total of 3/3, which is right here. And then 3/3 is just the same as 1. So if you had 4/5, use 1/5. If you have 3/8, use 5/8. So it's that process over and over again. And then down here in the last step, now we don't have a fraction exponent on the bottom, and that was the goal. So that's going to happen here in number 6. So let's check that guy out. All right, well, to start off, first rule when multiplying using exponents is to add the exponents. So I do have to add these guys up first. So you could use a calculator to do this, but I'm just going to tell you that -3/5 and -3/10 would add up to -9/10. So automatic got a negative exponent. That means I have to move them down to the bottom. And of course, when we move it, then our exponent isn't negative anymore. So here's what I was saying in regards to that last problem. If I had 9/10 as a fraction, and I multiply by 1/10, that'll give me a total of 10/10. And 10/10 is just the same as 1. So that's the point, is make it into a whole number. Now, automatic though, if you do multiply the bottom by something, I have to multiply the top by the same thing. So let me see if I can clean this up a little bit better over here. So if I do 1 times r to the 1/10 on the top, I get r to the 1/10. Granted, I still have a fraction exponent, but the numerator is okay. Anything can happen up there. So down on the bottom, again, right here, so I added up the 9/10 and 1/10, and I got 10/10. And 10/10 is just an exponent of 1. So yeah, I could have left that exponent of 1 off, but the important part is there's no more fraction exponent on the bottom, and it takes care of it. It's called rationalizing the denominator. All right, from here on out, if you are not in the Honors Algebra 2 class, there is no reason to watch these last 3 problems. If you are, stay tuned. So I hope you guys remember conjugates. I have a binomial on the bottom, 2 things. Therefore, I have to get rid of it by using 2 things. So a conjugate was just to change the sign in the middle. Multiply the bottom by something. Got to multiply the top by the same thing. So a little distributive property on top. 5 times that guy. 5y to the 1/2. 5 times that guy gives me a 15. So hopefully you remember when you do conjugates, it's just a FOIL problem. But it's a FOIL problem in which you don't have to do the outside and the inside. So if I just go first times first, remember the rule when multiplying is to add the exponents. And a half makes 1. So hopefully you could see, well, hey, that's getting rid of my fraction already. Last one times last one would be -9. And while that answer doesn't appear to be a whole lot better than the previous problem itself, we did get rid of the fraction exponent on the bottom, which is also understood to be a root, and it's called rationalize the denominator. So now, reducing fractions, I mean, hopefully you're thinking about that. There's a 5, there's a 15, there's a 9, but also this guy's understood to be a 1 right here. So I can only reduce fractions if I can reduce every single part. In that case, I can't. So while that seems like it's not a particularly good-looking answer, it is done. We have gotten rid of the fraction on the bottom, or the fraction exponent. Okay, 8 and 9 are just plain kind of funky. And this might not have occurred to you. But if I'm going to take the 6th root of 8, You put that on a calculator, you get a crazy decimal. So that's impossible at this point. Well, there's got to be something I can do to it. And the only thing, at least to me, that occurs that I can do to an 8, not exactly how this saying is supposed to apply. When in doubt, factor it out. But a 2, I'm doing a factor tree. It's 2 times 2 times 2. Oops, 6th root. So really, what I've changed that into is this. 6th root of, well, what's another way of writing 2 times 2 times 2, 2 cubed. And that is sort of the point with these. We are trying to mess with exponents. So, a little conversion, which we learned in video 1, part 1, if you want to watch that again, is to change a root into a fraction exponent. We take the inside exponent and put it over the root number, and I can reduce that down. So 2 to the 1/2 power. And if you wanted to, you could change it back into a root. It doesn't specify in the directions which one you had to do. So either one of these guys is acceptable for an answer. But if you think about it, look at the original problem. Square root of 2 versus the 6th root of 8. Well, that's definitely a simpler answer, and that's the goal of math, is to simplify. So if you're stuck with a number anytime, really, never a bad idea to try to think about doing this. So I'm going to go factor tree. And it's not like we haven't done factor trees for roots before. And what's another way to write 4 2's, 2 to the 4th power? All right, well, I never did actually do the 14th root of anything yet, so I do need to rewrite that. And then I'm going to pull out this little trick that we were talking about in video 1, which is to change fraction exponents into roots and roots into fraction exponents. So if I have a base of 2, inside exponent, outside root number, same thing. So what was the point? Well, hey, now I can reduce 4 over 14 down to 2/7. Now, again, that's acceptable for an answer right there. I didn't say in the directions which form you had to have. If you really felt the need to do it, you could change it into the 7th root of 2 squared. But then we're going to get you if you don't simplify and make the 2 squared into a 4. So this guy right here is acceptable. This guy right there would be acceptable. But either way, and I know how much you like these rules for math, those versions are both simpler than the original problem. And therefore, we did simplify it. All right, well, that brings us to the conclusion of section 8.4. Thanks for watching.